In this video we've got this Marshall JTM45 amp and it's coming for repair and it's marked as faulty, so we're not too sure what's with it. So I'm going to show you a few little things that I do with an amp like this on a typical service and repair job. Okay. So the first thing to do is to have a listen to this amp, and what I would normally do is I would use a dim light bulb if it was an unknown amp, just to power it up safely. And this is the effect of limiting current. And I'll just give you a little picture of what a dim light bulb looks like in case you're not aware. It's a light bulb. That's a 150 watt bulb in there, so that is great for this sort of size amp. And it'll light up a little bit if there's when it's in normal operation, but it'll glow brightly if there's a problem with the power supply. Okay, so I'm just going to fire the amp on. Stand by. Sorry, onto the mains power, and I've got an audio source that will plug into channel 1 here, and make sure the controls are in a sensible place. Let's have a listen. So straight away you can hear a crackle. I'm just going to show you the dim light bulb just to give you an idea of what's going on over there. So that's a sort of faint glow, indicates all is kind of normal. Can you hear that crackle? It's pretty annoying. So I think that's the fault they're reporting. Now quite often that will just be a noise coming from a preamp valve or a power valve, and we can, just by using a little ordinary chopstick, we can sometimes identify that. On this one, or maybe this one. So it could be preamp valve 2. It's not repeating, so maybe it's not that. Anyway, we'll keep that in mind. The amp is pretty new, by the way. It's a couple of years old. I think it's very recent, so it's not really age or wear and tear related, I don't think. The next thing we can do is have a listen to the controls. That fault, is it affected by any of the controls? Is it unique to one of the channels? No, it doesn't seem to make any difference. Oh, that's the treble control I'm just moving there. If you can hear that thump, I'm just going to show you the dim light bulb as I move that. We'll move the treble knob and watch the dim light bulb as well. As that noise comes, it's sort of glowing slightly brighter. It's interesting. Any of the other controls? The middle? No, nothing. Yeah, bass is making a noise. I don't like that. Presence? No. Okay, let's flip this up and see if there's anything interesting inside. So here we are looking inside of the amp. I'm going to flip that standby to on. And next thing I'll be looking here for is sort of any wires that are a bit loose or anything like that. And so just by moving any of these wires on the valve base with a chopstick, if there's any bad joint there, it'll probably show up with a bit of a click or a pop. They seem okay. Same goes to the power valves. Nothing there. Of course, this is very dangerous. So the precautions I'm using here are the chopstick is anything going near the amp. My other hand is in my back pocket. It's a sort of standard safety procedure. Yeah. This amp's got a valve rectifier as well, so don't overlook that. And you know, looking across the amp, there's no signs of any damage or any loose wires. These guys here sometimes can be a bit causes some trouble, so it's worth checking each one of these. I always do this with a Marshall, go across them. In fact, I've got another tool with a little hook on the end, and I'll go and make sure each one of these wires will support the weight of the amp really. And they often just pop out after many years, and the wires just lose their strength, or the solder joint loses its strength, I suppose. Okay, so if we remember, we did get more noise with the treble control, didn't we? And you could feel that. So I'm just going to get a meter on this and just have a little check on a few things. Let's just zoom out a bit so we can see the meter as well. Okay, so I've got my meter set up here. I think that's visible for you. Now, one thing that's useful to remember on pretty much all valve amps is that there should never be any DC present on the pots. So we're going to just check that, because I have a suspicion that this is a leaking capacitor, where the capacitor is supposed to block DC voltage, but when it leaks it'll let a little bit through, and if that can end up on a pot, then you'll get that responsiveness from the pot, which is what I'm suspecting. So it's a kind of useful little thing to remember, that you should never see DC on the pots. And the one exception for that is a presence pot, or a resonance control, which are kind of related, and the reason for the circuit's slightly different there, and they do have a small DC voltage. But we should never see that on any of these pots here, so let's just check those out. So that's one of the volumes, the loudness 2 on the wiper there. We can check the other connections as well, but yeah, they're all clean. Treble, oh, don't want to see that. 154 volts, I think that's, let me just clip on this, it's all visible. Yeah, that is not okay. These pots are not safe to have any voltage like that on them. So yeah, that's a problem. Okay, let's see if there's any more. That's the middle control. Yep, just checking. Yeah, middle. 9.3. Yeah. Well. Okay. And of course, these treble, middle, and bass controls are all connected together. So it's understandable if you have the treble, which is the top of the tone stack, has DC on it, then the others will as well. So that's worth having a look at. And there you go, on the presence control there's, oh, I'm blocking it with my hand, look at that. On the presence control there's 4 volts DC, so that kind of makes sense. A few other things worth checking. You can drop out some of these valves and check the plate voltages and things like that. Yeah, that looks good, 170. 260, that makes sense. Cathode follower, I think, there. Yeah, that's good. Okay, I think we want to have a look at the circuit diagram and work out which capacitor is feeding the treble. I suspect it's one of these two here, but I just need to cross-check that. Okay. Okay, so I've gone ahead and changed that capacitor. C8 is the one. And it's quite difficult to access the underside of this board in this amp because the cables are kind of as short as they can be. So often you have to just unsolder 1 or 2 little wires just to give you a bit of room to get around to the back of the board. So in this case I was able to do that by releasing this wire here, which is pin 8 on V2, and just by doing that it just gave you like another, I don't know, 2 or 3 centimeters movement. So it's possible to go and do that quite easily. And if you see now on the meter, I'm looking at the that treble pot, and I've got 0 volts on there, which is what I want. I want that cap to be doing its job of blocking. And now if we move that treble pot, hopefully, yeah, we get no bad noise. Let's just put my input back in. yeah, that's nice. So it's a nice smooth movement, and I think the other one was the bass pot was making a bit of noise as well. Yeah, that's fine. That's all cleared up. And this is the offending item here. Let me just zoom in a little. So what I quite like to do, something like this, is I feel confident that we've got the fault because the crackle seems to have gone, but it was a crackle that kind of did come and go a bit. But if we just measure this just to see what we get, well, look, let me get the meter in view so you can see. Oh, the amp's turned off, by the way, don't worry. In fact, it's isolated from the mains. We can see that it's measuring 50k. Well, that's a resistor value, so we know that this cap has got not a short, but a low resistance, so that's going to pass DC current. So that's why we're getting that DC voltage. So it's use. Not only is it confidence through hearing it's okay, we can now confidently say that that item is faulty. And yeah, I mean, it happens. Even new parts go wrong sometimes. So we need to wrap this one up and yeah, get it back to the customer. Oh, yes, useful. What other things go wrong with these amps? Well, there are a couple of other things. Let me just see if I can remind myself. Yeah, these guys here, these two raised resistors are the humdinger circuit for the amp. So they kind of ensure that the heater filament voltage is evenly balanced, and so it's a big noise reduction element. And on this sort of era, I've seen quite a lot where they've got the two resistors in this pot. There's this little balancing pot where this is whole toasted, and that's happened because the power valves have failed and some high voltages ended up onto the heater circuit, I suppose. And when that happens, the amount of current in through these resistors, which are I think 100 ohm, is excessive, and of course that just leads them to burn out. And no other real problems here. The Marshall's quite well made, I guess. The jacks, these guys wear out after about 10 years or so. Pots, of course, get damaged through use and so on. And I do occasionally see problems with this solder joint here, so always check these. Just a bit of lateral movement. It's not unusual that joint's not fantastic. And looks like those need tightening up a little bit. So I'll do that and then wrap this one up. Okay, thanks for watching.